What's up, everybody? So I've been getting a ton of feedback on the NFTs demos that we've done so far, and people said, hey, we want more. So this is going to be the ultimate NFT video right here. We're going to go everything end to end, building, deploying, viewing on Opensea, selling, the whole shebang, metadata, IPFS, everything in this video. So this is going to be the ultimate NFT video. So if you want to see a little bit more modularized version of this information, go check out my other videos. Links are in the description of deploying a simple NFT, an advanced NFT, and then all about NFTs as well. To start off, we're going to use the easy way of deploying an NFT. We're going to be using the NFT mix from the Brownie repositories. And then we're going to do everything from scratch. We're going to be deploying some super adorable puppies, and then of course, tattoo reveal at 10K subs. So be sure to smash that like button, hit the subscribe button, do all that YouTube subs, because I'm going to be showing you guys one of my tattoos at 10K subs. So hit the like, hit the subscribe. Easy way, hard way, let's jump into it. All right, so here is the repository that we're going to be working with. We're going to be working with the NFT mix. This is an official Brownie mix. We can even go to the Brownie NFT mixes here. Go in here, we can see NFT mix right at the top, and boom. This is the mix that we're working with here. This is using the Brownie framework. Obviously, Brownie is with Python. If you guys want to see a truffle one, again, definitely go check out the Dungeons and Dragons NFT for using Yarn, Node.js, and Truffle. This one's great as well. They have really cool characters in that too. But let's get started with this. Let's do this. So we are in our code editor here, and we're going to be starting because we have Brownie installed. We're going to, again, pip install fbrownie to get it going. You do obviously need Python installed. And now we're going to do Brownie bake NFT mix. Brownie bake NFT mix. I should spell it right. And great. Now we have this NFT thing in here, and it has all of the boilerplate code for us. Now, we're going to be doing this the easy way first. And the easy way is us just doing exactly what the README tells us to do, right? So let's follow the README. So we just Brownie baked. We need Node.js and Python. We've installed Brownie already. Great. We've cloned this repo. Great. We've already installed Ganache, right? So you do need Node.js, right? Node-v, npm-v. You do need Node, or you can also use Yarn or whatever you want, but you do need Ganache. And if you're watching this in the future, there will probably be an update to have this hard hat compatible, which will make it run even faster. But great, there are two main environment variables that we need. We're going to need our Web3 Infura project ID and our private key environment variables. Now, if you don't know anything about environment variables are basically variables that live in the shell. We can do export, Web3 Infura project ID equals whatever, right? And so we can get a Web3 Infura project ID. We can go to Infura. This is a way for us to connect to the blockchain. We can get started for free and sign up. Once you've signed up, there's a little project ID that you're going to get, and then you're just going to copy and paste that in here. Now, what you can also do is there's a .env, and you can put it, you can uncomment this out and put it in here, and this is going to be the same thing as if you had no idea what environment variables are. Put both of them in here, so whatever your Web3 Infura is, and then also your private key. So this is going to be found in your MetaMask. So you're going to go to MetaMask, account details, export private key, right? And so for our demo, we do need a RinkB link. And for our demo here, we are going to need testnet RinkB and testnet RinkB ETH. You can always find those in the Chainlink documentation. Link token contracts, RinkB, testnet link, testnet RinkB. We can get them from these faucets so that we have some in our contracts to actually use it. And I have another video, link in the description, to actually setting up MetaMask and getting that sorted if you have no idea what the hell I'm talking about. So once we have these two things set, you can do what's called source.env, and this is going to execute this file in our current shell, right? So it's going to be the same as if we wrote, export private key equals this, and export Web3 equals that. And those environment variables will now be in our shell. Again, if you don't know what environment variables are, link in the description to learn more. But I'm not going to do it because I already have my variables set. Now, great. What do we do next? We got those. Once you have those set, so let's jump into it. Now, if you ever get lost or you ever get confused, always refer to the README here, right? The README is going to give you exactly step by step what you need to do to be successful here. So if you get lost, always refer back to the README. If a step doesn't work that we do in this video, refer to the README, or also leave a comment and we will update either the README or update the description so that these tutorials stay fresh and they still work. We have two main types of NFTs in here. We have simple collectibles and advanced collectibles, and you can find those in the contracts folder. This is where all of our contracts are. So we have an advanced collectibles, we have a simple collectibles. Let's do both. Great, we're going to deploy the simple version. This is going to be your simple NFT. We're not going to go into what that means or what that even is, but let's go ahead and grab this and we're going to run it. So this is actually going to be deploying our contract to the Rinkeby testnet chain, and we're going to actually be able to view it on chain and actually create the collectible here. So anytime you deploy these NFTs, right, these ERC-721s, you're actually almost deploying what's called like a token factory. There's one main contract, and every time you run a CreateCollectible function, which we'll run in a second, you actually create a new NFT of that class, right? So our NFTs are going to be classes of dogs, right? These are going to be dog NFTs, but each NFT is going to be unique. Now, we also have one other parameter. Again, this is optional if you want. In our .env, if we want to be able to view these on Etherscan, we can also do this export Etherscan token equals this. Etherscan obviously being a method to view things on chain. Once we actually have deployed it, if we have that environment variable set, we can actually go to Etherscan and view and verify the contract, right? So these are interacting with that contract on chain. We can see that we've deployed our dog. We can see everything about the contract, right? So that is something else to look at. If we want to view these on Etherscan, make the export your Etherscan token. Again, you can just go to Etherscan, go to APIs, and sign up for your own API key here. Anyways, so we've deployed a simple NFT, and now we're going to deploy an advanced NFT. We're going to create a collectible. We can go check it out on Rinkeby. Yay, hooray, huzzah, right? So if we want to just get like the bare bones done, that simple NFT bit is going to get it done. Now, we will have to wait a little bit for both these transactions to complete and for Etherscan to verify our contracts if we've chosen to do so. So we can check out this contract. We can do whatever we want. I actually just redeployed, but anyways, we can do whatever we want. We can read and we can interact with it. Now again, I'm not going to talk about what these functions are doing or what's really going on here. We'll get into that after we go past this fast, easy version. But we can also see like the owner of different token ID. And right now, the owner ID of token ID 0 is going to be nobody, right? It's going to error. It's like, what are you talking about? It's not a real token, right? Because when we deploy this NFT contract, we're actually deploying a factory contract to create a lot of collectibles. Now, we could have made our contract in a way that it automatically deploys a collectible, but we didn't. So now we're going to call this CreateCollectible function, and this is actually going to mint our new NFT. It's going to create a simple, unique NFT, and we can actually view that I am the owner of the first one on Etherscan. So it looks like that has gone through. Now, if I hit query 0, we can see that this is my testnet address, that I am the owner of this collectible. So great. If you want to get just the bare bones done, you've just done it. Congratulations, but I'm quite sure that's not what you're here for, right? So we are going to go into what these functions are doing and what's going on here in a little bit. But let's do the more interesting stuff now. Let's get some stuff on Opensea. Let's get you selling some stuff. Let's get some images up. Let's get these NFTs to be really, really cool, okay? So let's continue to follow along in the README, right? This is why we have READMEs. This is why we have documentation, to make our lives easier. I'm ready to make some puppies! So same thing. First step, now that we have all those environment variables set, we are going to deploy our NFT contract, right? And we're actually going to be using a different contract. This is our AdvancedCollectible contract. What this one is going to be doing, I'm going to talk about it while it's deploying, is it's going to deploy a contract that's going to give us a random puppy every time we create a new collectible. It's either going to be a Shiba Inu, a pug, or a Saint Bernard, and they are adorable, right? So this again is going to be that factory contract, right? And this one actually, the Etherscan verifying is a little touchy, so this one doesn't work on Etherscan yet, but I highly recommend anybody who wants to help out and join the project to help out verifying these advanced ones. But it's not a big deal because we're going to see them on Opensea anyways. Now, we're going to do the same thing. We're going to create collectible. Now, I do want to talk about this function a little bit as we're going through this fast version. When we create collectible, we're actually going to kick off a chainlink VRF call, right? And to do this, we need to fund our contract with link. So behind the scenes, no, that's fine. So behind the scenes in our CreateCollectible function, we're actually first funding it with link, because in order to interact with a chainlink oracle, we need to spend some link. Same as how in order to interact with a Ethereum contract, we need to spend some Ethereum. We need to fund it with link first, and then we're going to kick off a request that's going to say, could we get a random number, please? That random number is going to get returned, and based off of that random number, it's going to generate the breed of the dog, right? So we're going to get a random breed of our dog here. So that's the function that we're going to be calling right here first. And again, right now we're just doing the fast version. We're just deploying it. We're going to build the whole thing from scratch in a little bit. So we're going to run CreateCollectible.py, okay? So this is going to interact with that contract that we just deployed. Excuse me. This is going to interact with that contract that we just deployed. It's going to now create our first token ID with it. This is going to be creating, this is going to request that we get a random dog breed back. And we actually will hang around for a little bit because we need to wait for 2 transactions to happen. We're calling on this function, right, to get a random number. Well, actually, we got to wait for 3 transactions. We're first funding it with link, funding our contract with link. Then we're creating a request to get a random number back. And then the Chainlink Oracle has to respond actually by giving us that random number. So we actually are waiting for 3 transactions here, so we do have to wait a little bit longer. Great, so now we've just completed the transaction here and even gave us what the dog breed is. So dog breed of token ID 0 is a Saint Bernard. We're gonna get a Saint Bernard. Okay, so, gotta relax. The cuteness is overwhelming. So, we've just created an NFT of a Saint Bernard. So how do we actually view this on Opensea? How do we show it off to the world? How do we do stuff with it? Well, in order to do that, we actually have to create metadata and then use that metadata to set the token URI. I'm not going to go into what that is quite yet, but let's just follow the instructions some more. So we're going to call this create metadata function, which is going to create this metadata file, 0saintbernard.json. Again, if we want to actually upload this image and upload this metadata to our own IPFS, we can, but we're just going to skip over it for now. You can go ahead and skip over the IPFS stuff too, because you're just going to use the one that I've uploaded and render that, so you're going to be all set. And I'll go over metadata again in the from scratch version, right? Because right now we're still just doing the Quickstart. So we've created some metadata. Now, with that metadata, we need to set the token URI of our smart contract to that metadata, right? And in this metadata file that we just created, it's going to give all the attributes of the dog. So we have the name, which is the Saint Bernard, which we got randomly generated from the Chainlink VRF. We've given it a description, and we've given it an IPFS image, which I'll go through again in the longer edition of this, and we've also given it a couple of traits, because, you know, why not? So once we hit that set URI function, we now get this message. Awesome! You can view your NFT at here. View your NFT of here. Please give up to 20 minutes and hit the refresh metadata button. So we're really, oh, look, it's already done. It's already got it. Excuse me, sorry. Anyways, so this is the NFT that we just deployed, and we actually didn't even have to refresh. Maybe Opensea is getting faster, which is great. So we didn't even have to refresh here. And this is the dog that we just deployed. So we can see its levels, its cuteness level 100. We can see a little bit about it, an adorable St. Bernard pup. And we can see that we just created this 3 minutes ago, right? This is the one that we just created. So now we can do whatever we want. We can list it, we can make an offer, whatever we want. And again, you do need your MetaMask on Rinkeby here to actually work. Like you can go to your profile and stuff and get signed in and change your avatar and do everything here. But this is the Opensea network, and it is connected to your MetaMask. So that is the quick start of this. That is the like, okay, you want an NFT? Boom, follow these instructions, let's go. Now let's break this down. Let's do this whole thing over from scratch. Okay, we're gonna do this whole thing over from scratch. Bear with me, guys. We're about to go through the long edition of this. All right, let's come back over here and let's restart everything from scratch, and we're gonna explain everything that's going on along the way, okay? I'm going to create this directory NFT from scratch, and we'll start there. All right, so we just did the quick start, and now we're going to learn how to customize these, how to build anything, and how to do anything with these puppies and with these NFTs, right? We're going to go through the long version and explain everything that happened in the code to get to that point. This way, you can make any type of customized NFT, any type of world that you want, all using these Brownie packages. So I know I just said that we were going to start from scratch, but we do need to at least start from a blank Brownie template. Now I'm partial to pretty much always starting with a chainlink mix, which we can run by, Brownie bake chainlink mix, which will have all the chainlink stuff and everything to work with oracles and random numbers and price and blah, blah, blah. I'm a big fan of actually starting there, but for the sake of starting from true scratch, we're actually just going to do a brand new Brownie implementation. So we're going to do Brownie init. And now we have a brand new Brownie project. So let's talk really briefly about what each of these folders is actually doing and what's going on. Because they're all going to start out blank, but they are going to give us what we need to get going. So the build directory is what happens when we build a smart contract and we deploy one on chain. This keeps track of every time we deploy a smart contract and where we're deploying it to. The contract section is going to be for all of our contracts. These are where we're going to put our Solidity code. Interfaces is a good place to put contracts that have already been deployed that we want to interact with. We can also put them in contracts, but if you're a little bit confused, ignore that for now. Reports are where we can put some reports. You can ignore that for now. Scripts are where we're actually going to put some of our deployments. You can also alternatively put them in a folder called deploy folder. But scripts are where we're going to do our Python that's actually going to deploy these contracts for us. And then tests are obviously going to be our tests. So the first thing that we probably want to do is we probably want to build our NFT contract. Now for this, we are going to do the advanced implementation. So there are going to be a lot of steps here, but this is really going to help you understand how to do everything that we're going to go over, including IPFS, storing the data, what is metadata, everything. We're going to be super, super thorough here. So the first thing that we want to do is we want to create this, this contract, right? So we're going to create a new file, and we're going to call it whatever we want to call it, right? AdvancedCollectible.sol. And this is where we're actually going to write our Solidity code here. So I'm going to make this a little bit bigger for everybody so that we can really see what's going on here. Now, the first thing that we want to do is we want to create at the top of every Solidity project, Pragma Solidity 0.6.6, right? So we're going to work with 0.6.6. Why? It's just the version that I built this contract in. So that's what we're using. Now, let's talk about what this contract is actually going to look like. And before we actually even go into that, we do need to understand what an ERC-721 is, okay? So let's go to OpenZeppelin. An ERC-721 contract is just a contract that follows a certain set of standards or principles. So when I say my contract is an NFT contract or an ERC-721, it just means that I have the same functions as every other contract that says that they are an NFT contract. Some of those functions are going to be token URI, minting, token IDs, and a number of other things, but they're going to all have this same functionality. Now we could 100% build a contract with all these from scratch, and we can even go to OpenZeppelin, GitHub, ERC-721. OpenZeppelin, they do a lot of different types of contracts. They are not the repository for storing this stuff, but they do a great job at building sample contracts. So we could 100% go through their copy paste this all into our code and follow the whole standards, right? Because an ERC-721 needs to have a name, needs to have a symbol, need to have owners, balances, token approvals, and all these functions that are in here. We could 100% rebuild everything, or we could actually just inherit from this OpenZeppelin contract. And that's actually what we're going to go ahead and do. So first thing that we're going to do, we're going to do import at OpenZeppelin/contracts /token /ERC-721 /ERC-721.sol. Now, in Brownie, we can actually just import things directly from GitHub with this syntax. And we have to do that in our Brownie config, which we haven't made yet. So we're going to go ahead and make this. So brownie-config.yaml. So this Brownie config is going to define a lot of stuff about our project, and we're going to be working with it a lot. So since we're going to be pulling from their GitHub, right? And we're just going to be pulling everything in here into our smart contract so that we don't have to rewrite and maintain all this code again. What we're going to do in Brownie is we're going to say dependencies are going to be OpenZeppelin/OpenZeppelin contracts. So in their GitHub, OpenZeppelin/OpenZeppelin contracts, this is what we're defining in here. And then we also want to define the release version. So they just did 4.0.0. I haven't actually worked with 4.0.0, so I'm actually going to use 3.4.0. This is the, 3.4.0. This is the most recent release before 4.0.0. So that's the first thing that we want to do. And the next thing that we want to do is we actually want to do a little bit of remapping, right? So we are going to be working with OpenZeppelin/contracts, but the syntax we're doing here is at OpenZeppelin/contracts. So how does Brownie know to turn this into at OpenZeppelin/contracts? Well, when we do the compiler of Solk or Solidity, we're actually going to remap, or we're going to do what's called remappings, and this is just the syntax here. And we're going to say at OpenZeppelin is going to be equal to OpenZeppelin/OpenZeppelin contracts at 3.4.0, and then save. So this is how our compiler of Solidity knows that, hey, we're going to be pulling from the OpenZeppelin GitHub, and then we're going to be remapping this to at OpenZeppelin, right? So now we can call at OpenZeppelin, which is going to refer to just this repository, and then we can go into whatever we want. So we're going to say at OpenZeppelin, and that's actually how we can import anything from GitHub into our Brownie projects. Great. And we're going to do that same thing, actually, with Chainlink, okay? Because we want to use the Chainlink VRF to get a provably random breed for our dogs. Getting randomness in our NFTs is a great way to make proven and true scarcity. So in our smart contract, we're also going to do import at chainlink/contracts/src/v0.6/vrf consumer-base.sol. And we have to do the same thing in our Brownie config, and just ignore this little squiggly line. It's just annoying VS Code. So we have to make another dependency, right? So what's our dependency here going to look like? Well, in the Chainlink GitHub, there's actually a package specifically for Brownie right now. So smart contract kit. You can even just look up Brownie. And we have chainlink-brownie-contracts, which has the same thing, contracts, and it's just a whole bunch of contracts for Brownie. Depending on when you watch this, that actually might get wrapped up into the main repository here, but we'll see. In any case, if you get lost or confused, always check the README, check the config, go ahead and use that, but this repo will likely be here too. So again, so we want to use smart contract kit / chainlink brownie contracts at 1.0.2, right? Because if we look in here, if we go back in here, we can see the latest release is 1.0.2. And of course, you can use whatever release that you want. We're going to use 1.0.2, and then we also want to remap this as well. So let's go ahead. We'll create a new entry here. We do at chainlink. So now anytime we reference at chainlink, we're really going to be saying it's smart contract kit dash chainlink brownie contract. Excuse me, contracts, pardon me. Contracts there as well at 1.0.2. Okay? And excuse me, this is OpenZeppelin. OpenZeppelin. Apologies. And now we can do a Brownie compile, and we should be able to compile our smart contract here. Great. So we are able to compile our smart contract. That means that we didn't screw up any spellings or any typos up here. So great. That means we're doing things correctly here. So now that we have our two imports, we need to actually start creating our contract here. So we're going to call it contract AdvancedCollectible is ERC-721. So we're inheriting this code that we just looked at, and we're also inheriting the VRF consumer base, which I didn't go into, but this is what's going to allow us to use randomness in our smart contract. So we're also going to say is VRF consumer base. Great. We can even try to compile this. And we get an error because it's saying, hey, you inherited these contracts, but you didn't do what they said that you needed them to do. So we'll do that. So your Brownie compile will now start failing, but don't worry about it. So great. Now we need to do, let's jump into building this contract. So we need to make a constructor. And in our constructor, we need to pass it a couple of things. So we need to pass it our VRF coordinator. And again, if you haven't used the Chainlink VRF before, head over to docs.chain.link. Scroll down to randomness, get a random number, and just click this button, and you can do a remix version of it. And then just follow the instructions here to kind of do that with remix, but you'll also see it in the contract that we do. So we need to pass it a VRF coordinator. This is actually what's going to prove and get our provably random number. We have to pass the address of the link token. We have to do the bytes 32 of the key hash, which the key hash, along with the VRF coordinator, is going to be used to prove that a random number is actually random. And then that's it. Then we're going to make this a public function. Now we have to add the constructors of the ERC-721 and the constructor of the VRF consumer base in our constructor. So we're going to say VRF consumer base. It needs the VRF coordinator, and it needs the link token. And then we also have to do the same thing for the ERC-721. And the input parameters for the ERC-721 are going to be the name and the symbol. So what is the name of our NFT factory contract? We're going to call it doggies. And we're going to have the symbol be dog. Boom. And this is going to be our constructor function here. Now, if this part confuses you, don't worry too much about that. Again, we just need these addresses to work with the chainlink VRF. We need the key hash too. We're going to get to that in a minute. But for all intents and purposes, just giving it the name doggies and the symbol dog is going to be the main starting point for us. Now, we do have to do some stuff in the constructor, but we're just going to go ahead and move on conceptually to what makes sense. So we've deployed our constructor, we've deployed our factory contract, and we're going to need a function called CreateCollectible or CreateDoggy or whatever we want to name it. And this is the function that we want to call whenever we create a new NFT and create a new token ID for that NFT. Remember, when we deploy this contract, it's really just a factory contract, right? It's the boilerplate contract for creating NFTs of type doggies/dog. So we need a function, CreateCollectible, and what do we actually want this to take in as its parameters here? Well, the main thing that we actually need is a uint256 userProvidedSeed. This is going to be a number that we actually input that the Chainlink VRF is going to use to prove, again, whether or not the number that it gives us is truly random, right? And this is really important for creating that scarcity that we want. The other thing that we're going to need to pass in is a token URI. Now, what is a token URI and why do we need it? Let's finish this function. We're going to say it's public returns. We can even move this over just a hair. Public returns, we're going to say a bytes 32. Okay, so what is this function actually going to do? We want this function to be the one that creates our collectible for us, and it creates that, it kicks off a request to the Chainlink VRF to return a random number to create us an NFT, okay? So let's talk about token URI for a second. What is token URI? If we look into the ERC-721 or even the EIP, ERC, EIP, they basically mean the same thing. One means request for comment, the other means Ethereum improvement proposal. And we look up token URI. We can see them define what a token URI is, right? And we can understand what a token URI. So a token URI is a distinct uniform resource identifier for a given asset. The URI may point to a JSON file that conforms to the ERC-721 metadata JSON schema. Okay, what does that mean? When we deploy a token URI and when we deploy an NFT, we want these NFTs to have pictures, right? When we deployed the doggy earlier, it had a picture of a dog. Now, deploying entire pictures are a lot of data, right? And I don't know if you guys have known this, but generally deploying a lot of data means using a lot of gas. Using a lot of gas means very expensive. So something that NFT creators thought of when they were building the ERC-721 standard was how do we actually render these images without having to deploy that whole image on chain? So they said, here's what we'll do. We'll give it a token URI or uniform resource identifier. This can be an API call. This can be an IPFS link. This can be any URL or API or whatever that points to a specific JSON file, okay? And the JSON file is going to look something like this. I'm actually going to pull an example from the pugs that we were making earlier. So the JSON file is going to look like this. So when we call an API, we want it to return something that looks just like this. It needs to have a name, a description, an image, and then attributes. This is just for rendering purposes. We obviously want to still have these attributes on chain if we want the tokens to actually interact with each other and do more things than just be art, right? If we wanted to have a game character, we would need to have it actually have some type of strength on chain, right? So we have to put it both in the token metadata and on chain. So in any case, that is all the token URI is. It's just an API that returns something that looks like that. The question then, of course, becomes is, Well, where do we store this, right? If we store it in a centralized server or centralized API, then in 10 years, our NFT is going to be nothing, right? So a good solution to this is actually storing these images on IPFS, and this is actually what we're going to do here. IPFS is a peer-to-peer network, but basically IPFS is a network in a decentralized manner where we can store data, and we can store this information. Now, to keep it persisting there forever, we do have to reach out to other node operators and have them also host our data, or we can use some type of persistence network like Filecoin to make this permanent, right? We're not going to go into too much of that here, but IPFS is going to be a decentralized way for us to store our data. Let me just show you another example of what one of these looks like. Here's what it looks like on IPFS. We can share the link, copy the link, and we can paste it into our browsers and actually see it. So I have this thing called IPFS Companion installed in my Brave browser here. It's just a plugin. We can add it here. We can actually see this is going to be the API that these NFT marketplaces are actually going to be calling when they work with our stuff. So, and you can see it has this image section, which we can also copy and paste. And we can see this is the image of the dog here. That's what a token URI is. So when we create our collectibles, we're going to have to set this at some point so the NFT marketplaces know what to do. We're going to have to set this JSON file. Now, for the purposes of this demo, we're actually going to leave that blank at first until we've uploaded our metadata to IPFS based off of the characteristics and the traits of our dog on chain. Once we found out the breed of the dog, we'll make the token URI and we'll set it on chain. You'll see how we do it in a second here. So the first thing that we need to do is kick off our randomness request to the chainlink-brownie-contracts, right? And remember, this is going to be asynchronous. So when we call CreateCollectible, we're going to be calling this function, and it's going to emit a request to get a random node from the off-chain Chainlink Oracle. That's going to respond in a second transaction that we're going to define below. That function is going to be the one that actually creates the token ID and everything that we need. So for CreateCollectible, let's just do the chainlink-brownie bit here. So we're going to do bytes 32. Request ID equals request randomness, key hash, fee, and user provided seed. The key hash and fee we need to pass to the chainlink-brownie. The key hash is used to actually verify the number is truly random, and then the fee is going to be how much link token we're going to send to the Chainlink Oracle. Remember, when working with transactions on Ethereum, we pay a little bit of ETH. When working with Chainlink Oracles, we pay a little bit of Link. So here up at the top, we're actually going to go ahead and define those as global variables. So we're going to do bytes 32 internal key hash, and we're going to do uint 256. We'll just do public fee. And we'll even set the key hash and fee in the constructor. So we're going to say key hash equals key hash and fee. This one we are actually going to hard code to 0.1 link, which we have to do in way. So we're going to do 0.1 times 10 raised to the 18th, which again stands for 0.1 link. Remember, when working, Solidity doesn't work with decimals very well, so it actually, so this number is actually 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's actually 18 zeros, right, which stands for one link. But it's just kind of like a little bit nicer visual to be like, oh, okay, it's one link. So we're going to hard code that. So this is the requestRandomness function, which kicks off the chainlink-brownie call to get the random number and return it back to here. We do have to do a couple other things in this function. When we request this random number, we want a way to know that the random number that we requested is the same random number associated with the request. When the Chainlink node returns, it's going to return and assign the random number to the correct call. So we actually have to do a little bit of mapping here, okay? So when we have to know that when I make the request, when I create a collectible, the random number that gets returned is returned correctly to me, right? If someone else calls CreateCollectible, the random number that was kicked off when they called it needs to be returned to them. So we have to make a quick mapping here. So we're going to do request ID to sender of request ID equals message.sender. And we're going to create a mapping at the top called request ID to sender. So we're going to do a mapping of bytes 32, request ID, mapped to address, and we're going to call it public request ID to sender. Okay? So this is when I create the request, that request is associated with me, message.sender, me. It's all about me here. And we also, let's say we did set the token URI, we'd want to do request ID to token URI, request ID equals token URI. Now, we're like I said, we're going to be defaulting this to blank, but if you did want to set the token URI right from the get-go, this would be the way that you do it. So we also have to do this mapping. So do mapping of bytes 32, request ID to string, public request ID to token URI. Again, the token URI being that API call to that JSON response. Okay. So now we have request ID to token URI as token URI, and we're also going to do one more thing purely for testing, for when we write our tests. We're going to omit a requested collectible request ID function. Now, this is going a little bit into events here. So we're omitting an event. An event is the closest thing to Ethereum logging that there is. It's spit out. We can't actually access events on chain, but we can read them from off chain. But we have to create our event type. So we're going to say event requested collectible. It's going to be a bytes 32 indexed request ID. So we're saying we have this event. Again, this is like Ethereum's version of logging. Our smart contract can't interact with events, but we can interact with events and we can use them for testing. So we want to make sure that our request ID is happening and is the right one. So we're going to omit that request ID. So this is going to be the starter, the main piece of creating that collectible. Now, once the Chainlink node responds, we're going to want to fulfill randomness. So we have to create a function called function fulfill randomness, and it takes a bytes 32 request ID, a uint256 random number, and it's actually going to be an internal override. Internal override. When we kick off a randomness request, the Chainlink node responds by calling this fulfill randomness function. It actually calls something through the VRF coordinator, which calls this, but don't worry about that for now. And it's going to return with that request, that original request that was created up here, and that random number, right? Because we were requesting a random number. So it's going to return, it's going to say, hey, here was the request that I got, here's the random number. And the VRF coordinator has already processed it, already made sure it's a provably truly random number. This is how we can create that beautiful scarcity that we're looking for. So now we can actually start setting it up and actually mint this new NFT and this new token ID. So let's do this. So we need to get the address of the dog owner. All right, we need to get the address of the person who originally created this request. And since we saved it in a mapping, we can do request ID to sender of the request ID is going to be that dog owner, right? Because above here, we mapped it out. Request ID to sender of request ID is message.sender. Down here, we're going to unpack it from that mapping. Okay, so now we have the dog owner. We also need the token URI, string memory, just in case we did set one. So string memory token URI equals request ID to token URI request ID. So this is going to be doing getting the token URI that we initially added when we called CreateCollectible, which again, we're skipping for now. Now, every time we mint a new collectible, every time we mint a new NFT on our NFT factory contract, we have to give it a token ID or a new ID. So we're going to say uint256 new item ID equals token counter. So we need to keep track of all of the tokens that we're making. So we need to add another variable at the top. uint256 public token counter, and we need to initialize it to 0. Well, we don't have to, but we're going to. Right, and it's going to default to 0, so our first token ID is going to be 0. Now we're going to call a function that we've inherited from the Opensea ERC-721. It's going to be called safeMint. Now we're going to safeMint an NFT, and we need to give it the owner, which is going to be the dog owner, the one who initially hit that CreateRandomness function, or excuse me, CreateCollectible function, and then we have to give it the ID, which is going to be new item ID. We also typically want to set the token URI. So we can do set token URI of that item ID to that token URI that we originally sent in. Again, for us, it's just going to be none, but I did want to show the functionality here from the get-go. Because if you wanted to give it a token URI from the get-go, you absolutely can. Now, here's where we get to have some fun. We are going to be using this random number to be choosing a random breed, but we could do a whole lot more than this. We could give our dog a speed stat, a color stat, a random, any type of random attribute for our NFT. And again, the Dungeons & Dragons one does a great job of that. The Dungeons & Dragons demo, it gives like random strength, dexterity, constitution, etc. We're just going to be doing a random breed here. So we need to actually get a list of random breeds that our dogs could be. So we're going to use this by doing an enum. So we're just going to do 3 dog breeds. So we're going to say we're basically creating a new type here, of type breed. So we're going to say enum breed, and you can be a pug, a Shiba Inu, or a Saint Bernard. Okay. Now we have this new type breed, we can actually make objects of this type. So down here, we're going to say breed. So variable name is breed, of type breed, and then maybe we even call this like dog breed or something. That's probably better, but I'm just going to stick with breed. Equals a new breed of one of those 3. So if it's a 0, breed is going to stand for pug. If it's 1, oh, and then actually, this doesn't need a semicolon, sorry. Pug is going to be, if it's a 0, it's going to be a pug. If it's 1, Shiba Inu. 2, Saint Bernard. 3, nothing. It's going to error out. So we're going to say new breed, and we're going to use that random number to actually give us the breed. So we're going to do what's called the modulo function. Random number mod 3. This is basically, it's going to divide the number by 3 and use the remainder to actually choose. So if it was 9, 9 divided by 3 is 3 with nothing left over. So it would be 0. There's no remainder. Now if we did 10, 10 divided by 3 is like 3 point something. Another way to put it is that there's 1 left over, right? Because 9 divides evenly. 10 has 1 left over. It would be 1. So that's how the modulo function works. So this way we'll always get 0, 1, or 2, right? Because we can't get 3 because 3 divided by 3 is 1. So great. So now we have the dog breed. Now we actually need to assign that dog breed to this new token ID. So we're going to do token ID to breed. We're going to create a new mapping here. Token ID to breed, new token ID. equals breed. So we need to create this new mapping up top. And as you can see, we're starting to get a lot of mappings. Another way to do this is actually with a struct of type breed to kind of store all this in there. But this is just one implementation. I thought it would be easier, but another way to do this would be to make these structs. So we're going to do uint256 token ID to breed, because again we have that new breed type, public token ID to breed. Now we also need a way, when we're testing, we are also going to need a way to map up the request ID to the token ID so that we know that it's right. So we're going to be adding this in for some testing as well. We're going to do a request ID to token ID of request ID equals new item ID. So again, at the top, we're going to create this new, and again, you'll see why we need this in a bit. Mapping of bytes 32 to uint256 public request ID to token ID. Boom. And then we just need to iterate the token counter. So token counter equals token counter plus 1. Right, and this way, every time we create a new token, it's going to have a new ID. So great, we've just implemented the main functions that we need, and technically we could just go ahead and send this, and this would work. Now, obviously we would need to set the token URI correctly from the get-go, but we'll fix that in a second. So let's actually compile this. Let's see if we did anything wrong here. We did a couple of misspellings, so let's actually fix that. Bytes 32, VRF consumer base. And let's see if that works. And great, our contract compiles here, which means we don't have any glaring issues at least. So we do need one other function. Right, because since we don't know the breed of the dog before it gets created, we actually have to add the breed to our metadata, to our token URI later. So we're going to create a function called setTokenURI. And this is going to set that token ID to the correct token URI. So we're going to do uint256 token ID. We're also going to do string memory underscore token URI, and we're going to make this a public function. Now, even though we are going to make this a public function, we really only want the owner of this token ID, of this little doggy, to be the one to be able to set the token URI. That's where we can do this require statement. And we're going to, again, this is imported from that ERC-721 Open Zeppelin. We say is approved or owner underscore message sender underscore token ID. So this is imported from that ERC-721 from Open Zeppelin. They have a function called is approved or owner. And this just says, hey, is the message.sender the owner of the token ID? That's all this is doing. And then if they're not, we'll have it kick out a message, ERC-721. Transfer caller is not owner nor approved. Great. And then we can just call set token URI, token ID to token URI. Right, and this is going to be the same method that we called above. Set token URI, but we're just calling it in its own function here. Okay. Now again, let's see if it compiles. Awesome, we now have it compiling. Now in the NFT mix and in the Chainlink mix, we actually go ahead and write some tests, right? Writing tests for your local network is really, really big. And I've even imported the conf test into this test folder. We're not gonna go over the tests here, okay? But you definitely want to actually test a lot of your stuff locally before you deploy it to a real testnet. Because even though a testnet is free and you can get your testnet link and you can get your testnet ETH, you're going to be able to test much faster if you test on a local chain first, okay? And then to do that, we actually do need to download Hardhat. We actually do need to download Ganache, and in the future, we'll update this package for Hardhat as well. So you can see if you have Node with Node-V, again, you can go to download Node, Node.js, download Node.js to actually get that. And then you're going to need to npm install Ganache, right? npm install -g Ganache CLI. Again, I'm not going to do it because I already have. So that's how you're going to need to run your tests. You absolutely should 100% in your development experience do that. We're going to skip over it. So now we're going to write some scripts, right? We're going to skip over, we're just going to jump into writing some scripts here, okay? So we're going to create a new folder just because that's what the mix has, Advanced Collectible. And in this folder, we're going to create our functions to actually do things. So our first one is going to be deploy AdvancedCollectible.sol, okay? And this is our contract to deploy the advanced. Now we can 100% wrap all the scripts that we're going to write into one big script, but I'm going to go ahead and break it apart so that you kind of can understand a little bit more what each step is really doing. Okay, so this is going to be deploying our smart contracts to the Rinkeby testnet chain. Okay, so we're going to do from Brownie import. We want that advanced collectible. Advanced collectible. We want accounts. These are going to be accounts associated with our private key or our mnemonic. We want network. We want to know what network we're on. And we also want the config. Now, I know I'm typing a lot of stuff here. You'll see what it is in a second. This is, excuse me, not .sol. I was wondering why I was highlighting weird. .py, excuse me. And when we run our scripts, we can actually run them like this. We can do brownie, run, scripts, advanced collectible. Oops. Sorry, let me actually put that in the right folder. Deploy advanced.py, right? And it's not going to do anything right now, but it's just going to spit out. Now, as you can even see, it says launching Ganache CLI. This is because the default network of Brownie is going to be a development network where it launches Ganache, okay? And it calls the main function. We haven't had it do anything, but we could do something like print hello. Now we do Brownie run scripts, advanced collectible, deploy advanced, hello, and that's it, right? So it compiles everything and runs the script. Great. So let's have it actually do what we want it to. So the first thing we need to do is, since we're deploying to a real chain, we need a wallet. We need an address. We need a private key or mnemonic. So we have to add that to our accounts. So we got to do accounts.add our private key or whatever. Okay. We're actually going to define this private key in our config, our configuration. So in our config, we're going to make a new section called wallets. We're going to do from key, private key. And this is how Brownie knows how to get our private key from the environment variables, right? So you see the syntax around it? This currently means get it from an environment variable. This just means it would be private key, but we want the environment variable. We could also do from mnemonic and do like, mnemonic if we wanted, but now we can actually have our key or mnemonic stored in our config. And again, you can get that from here, account details, export private key. okay? So now in deploy advanced, we have to add our account here. So we're gonna do accounts.add config. This brownie config here pulls from our brownie config, and we're gonna say at wallets. So at that wallets section, and then we're gonna do from key, okay? We could also do, I think it's from mnemonic. I think that might be it. I'm not sure. And then we can do from mnemonic here if we wanted to use our mnemonic instead. But we do accounts.add, and now we can do, or we're going to say our dev account equals accounts.add this. We can even do print dev, right? And hopefully this will print our account, right? This is my MetaMask address, so great. So we are adding our account properly. Fantastic. Now what I also like to do is I also like to just do this print network.show active, just so that we know what network that we're working on. So we'll run this again, we'll see what we get. We're on the development network. If we want to change networks, we can do -- network, RinkB, and it'll say, okay, great, now you're on the RinkB network, okay? We don't need to define anything in here because Brownie knows what our networks are. So if we do Brownie networks list, it already has some pre-built into it. For example, RinkB, Coven, Ropsten. I've added a bunch in here, so these are the ones that I've added, but it has a whole bunch built in. Now there is currently, we're gonna skip over publishing to Etherscan, just because again, there's currently an issue with doing it here. So I'm gonna set this variable publish source equal to false, and you'll see why we'll do that in a second. So now let's go ahead. Now that we have an account, again, we have it funded with Ethereum and with Chainlink, we can go ahead and deploy our collectible here. So we'll do AdvancedCollectible. We'll call it AdvancedCollectible, lowercase, equals AdvancedCollectible.deploy, right? Because again, we're importing this smart contract from Brownie, and we're just going to deploy it with AdvancedCollectible.deploy. Now, what do we deploy it with? So remember, when we set it up, the constructor said it needed a VRF coordinator, link token address, and a key hash. We could absolutely 100% hard code it here, but we're actually going to do something a little bit more clever. So in our Brownie config, we're going to create a networks tab, or a networks section. We're going to set the default to be development, which it already is. But if we wanted to run this on Coven, if we wanted to run this on RinkB, the addresses of the VRF coordinator, of the link token, of all these other things are going to be different, right? So we want to specify that when we're working with the RinkB chain, we're going to use specific addresses, right? So the VRF coordinator is going to be a certain address. The link token is going to be a certain address. All these other things are going to be a certain address. Now, again, I'm just going to copy paste here. But if you're like, whoa, what are all these things? You can go to the Chainlink documentation and find all these addresses here. So this is the address of the VRF coordinator on RinkB. This is the address of the link token on RinkB. This is the key hash. Again, this is what the Chainlink VRF uses to make sure our number is truly random on RinkB. And then this is the fee of the VRF on RinkB. I think we can actually even get rid of that because I don't think we ever do anything with that. So now, in our deploy advanced script, we got to add those parameters that are in our constructor, right? And again, oops. If we look in here, VRF coordinator, link token, key hash, and we can do it on a per network basic. So we'll do config, networks, network.show active, VRF coordinator, right? So we're saying from the config, go to the network section, go to the active network, which is RinkB, networks, RinkB, VRF coordinator. Networks, RinkB, VRF coordinator. But now we got to do that for all of them. So we're going to do config, networks, network.show active, link token, config, networks, network.show active, key hash. Great. And every single time we deploy a smart contract or work with a chain or make a transaction, we always have to add this from object from dev. And this is also where we'll define anything else. So we're saying we're deploying from this dev account. And we can also do publish source, and this will verify it on Etherscan if we have our Etherscan API key environment variable set to publish source, which again, we're just defaulting for false, at false for now, okay? So when we deploy this, we also, again, we need to fund it with link. So we're actually going to put this fund script, we could put this fund script in here. I'm actually going to go ahead and put it in its own script. So what I'm going to do is I'm going to create a new function called, or a new script called FundCollectible.py and put it right where I want it to be. And we're actually going to define that in here. We get 100% define it in the deploy advanced script, but I want it to be its own script. So I'm going to say from Brownie, import AdvancedCollectible. I also made a helpful scripts file in here. So we're actually going to make that too. CD scripts. We're going to touch helpful scripts.py, and actually we're going to put it in there. So we're going to open this helpful scripts, and this is actually where we're going to put it. So we're going to go from Brownie. We're going to put it in here. We're going to import in FundCollectible and import that into deploy advanced. You'll see. So we're going to do from Brownie, import AdvancedCollectible, accounts, config, interface, interface, network. Import a whole bunch of stuff in here, right? And we're going to add this function, def fund advanced collectible, and we'll have it take in an NFT contract as the variable to start. Oops. And again, we're going to set the dev account, dev equal accounts.add config wallets. I guess we could pass that, but we're not going to. Wallets from key, right? Because since we're going to be funding it, we do need to fund from an address. And we also, now we need to send the link token. Now here's where interfaces become really helpful. Whenever you interact with a smart contract on chain, you need two things. You need the interface or ABI, and you need the address. The interface is secretly a way to get the ABI. What is an ABI? An ABI defines the way to interact with a smart contract. So you always need that ABI and the address, okay? We're going to be getting the ABI from the interfaces section. So we're going to actually create a new file called link-token-interface.sol, and I'm just going to copy paste. So as you can see, it's just like a list of functions. This isn't a real smart contract, but it shows us what we can do with the link token, right? We can approve it, we can transfer it, it has a name, it has a symbol, blah, 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 whatever, okay? And we need this to actually interact with the Chainlink token and send and transfer and fund our contract. So we need that, and we also, like I was saying before, we also need the address. So from our interface, from the interface folder, which we get from Brownie, interface.linkTokenInterface, the one that we just made, and again, you can copy it from the NFT mix, it's in there. We need the address. So we're going to do config networks network.show active link token. Link token, right? Because every network is going to have a different link token address, okay? So the Rinkeby chain, this is the address of that token. So we're saying, we're going to say, hey, let's get the address from RinkB of that link token, and we're going to wrap it in this interface. So we have the address, this is how we get the address, and this link token interface is how we get the ABI. We can even make this easier. We could say link token equals this. Then we can call link token.transfer. Now that we have the ABI and the address, we can actually do stuff with it. We're going to do link token.transfer, NFT contract. So we're going to send that NFT contract some amount. We'll do 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll send it a whole link. Or actually, I think in the mix we send 0.1 link, so we'll do that. So we'll send it that, and then from, right? Because we always need to from dev. Okay. So now we have this fund advanced collectible. Right. Good thing we fixed that. So now in our fund collectible script, we can actually import that function from scripts. That helpful scripts, import fund advanced collectible. And we can just have this function, or this script, be really simple. Def main advanced collectible equals advanced collectible. And here's how we actually can get the most recently deployed contract. So this advanced collectible object that Brownie gives us is actually a big list. So what we can do is we can get the length of this advanced collectible list -1, and now advanced collectible. This advanced collectible is going to be the most recent deployment of advanced collectible. This advanced collectible instance is going to be the most recent one, and we're going to do fund advanced collectible, right? So we're going to be passing the most recently deployed advanced collectible to this fund advanced collectible script, and boom, great. So now back in our deploy advanced function, we can actually import that same way we did before. I'm just going to copy paste from scripts.helpful scripts.import fund advanced collectible, and we can run fund advanced collectible. And what are we going to pass? What are we going to pass? We're going to pass that advanced collectible, that advanced collectible, and then let's return. Oh, let's do it like this. And we're going to return the advanced collectible. Whew! What a mouthful. Okay, so now we have a function that deploys our contract and then also funds it with link. Okay? So the only other thing that we need, again, is we do need our Infura. Right? Like I said in the Quickstart, we do need the Infura. Get started for free. You can sign up and get your Web3 Infura. It's going to be your Web3 Infura project ID. This does need to be an environment variable, right? And again, if you forget how to do that, you can do export private key equals blah, blah, blah. You can create a .env file and do export private key equals blah, blah, blah. And then just do, and then obviously, export Web3 blah, 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 whatever it is, equal to, whatever it is. And then you do source.env, and that'll actually run these exports in your terminal. We can also do the py.env, but we skipped that for this. But if that's confusing, don't worry about it. But let's go ahead and at least test this, see if it works on RinkB, okay? Because right now it's not really going to work on development, because now we're kind of hard coding this to work for development. We're going to say, hey, in the networks tab of the network, get the VRF coordinator. And if we go to the brownie-config, obviously, there is no VRF coordinator for development. So let's go ahead and test this. Okay. Brownie, run scripts, deploy advanced network, RinkB. And great, it looks like it's actually working properly. We have a transaction here, and we should be able to go to etherscan rinkb, paste it in, and it actually looks like we are getting a transaction here. So this first transaction is, of course, going to be actually deploying the smart contract, right? It's going to be deploying the smart contract. We will have to wait for a second transaction, which happened right here, which is going to be funding it with link. So great, it looks like we've actually deployed a smart contract, it's been created, and we can see it's been funded with 0.1 link. So this is great. We now can see that we have this contract on chain, it's been funded with link. Awesome. Now we actually need to interact with it, right? We have these other functions in our AdvancedCollectible.sol that we need to call, right? We need to create our collectible. We need to, which is going to kick off the function to get a random number, to fulfill it and create the actual collectible with the token with the new token ID. And then we also need to set the token URI, right? We need to store our data someplace, IPFS, etc. server, whatever. We need to store it somewhere so that when Opensea goes to render it, it knows what to do, right? Because if we take this right now, it'll show up, it'll come up as blank, right? It'll say, hey, I don't know what you're talking about. This is just an NFT. It means nothing to me though, right? And that's clearly not something that we want to do. So we need to write the rest of these functions here. So we need to write a CreateCollectible function, which is going to call that. We can also do this from the console, like the brownie console --network rinkb, but we're going to skip that. So, and if you even look into deployments now, we can see we have a deployment for rinkb in our build folder over here. So great. So we have deployed it, we've funded it. Let's create a new one called CreateCollectible.py. And this is actually going to create the collectible. Now, again, we could just wrap these all up into one script, but we're going to put them in their own scripts just to break it down for us here. So we're going to do the same thing here from brownie, import AdvancedCollectible, accounts, config. We're also going to do, we're going to also create a new function in those helpful scripts called getBreed. We're also going to import time. You'll see why in a second. So you'll see why we need getBreed. We haven't made it yet. You'll see. So let's create our main function, def main. Again, we're going to do dev equal accounts.add config wallets from key, right? This is the same as before. We're just getting our dev account from our private key. And we're going to do AdvancedCollectible. We're going to interact with that contract that we just deployed equals AdvancedCollectible. And again, we could do like 0 here. We could do 1. We could do 2. We always want to get our most recent one. So we're going to do the length of AdvancedCollectible minus 1. So when we call this, we're just auto hard coding it to always work on the most recent deployment of AdvancedCollectible. And great, now we need to call that transaction, that CreateCollectible transaction. So we're going to say transaction equals AdvancedCollectible dot create collectible, and we're going to give it a token URI of none for now, just for now, and we also need to give it a seed, right? And this is what the VRF uses to get that random number. So we're going to do static seed equals, we're just going to call it 1, 2, 3, static seed, and again, since we're making a transaction, we always got to do this. Whoops. Sorry. From dev, from that account, okay? So now we're going to do transaction.wait. We're going to wait for 2 confirmations or 1 confirmation or whatever we want to do. We're going to wait for that transaction to actually finish. And then this is where those mappings are going to come into place because we want to get the breed of this dog. So we're going to get the request ID of the dog by actually grabbing that event that we made, right? Because in this AdvancedCollectible, we had this emit requested collectible. So in our transaction here, we can do transaction.events and requestedCollectible. In that requestedCollectible event, we're going to get the request ID, and then we're going to get the token ID based off that request ID, because remember we set those before. So we're going to say token ID now is going to be AdvancedCollectible.request ID to token ID, request ID. So we're grabbing the request ID from that event. We're going to get the token ID based off of that mapping of request ID to token ID. Okay. Then we're going to get the breed now based off of that token ID. So now breed is going to be get breed AdvancedCollectible.token ID to breed of token ID, right? Because we also in here, we have token ID to breed. So this is how we're going to get the breed, token ID. And then we're going to print out the breed. Now we don't have this get breed function because we haven't defined it yet. So let's create it. So we're going to do def get breed in this helpful scripts function. And we're going to do breed number, right? Because again, it's going to be 0, 1, or 2. 0 being Pug, 1 being Shiba Inu, 2 being St. Bernard. We're going to add this little dictionary. We're going to call it switch equals 0 is going to be a Pug. 1 is going to be a Shiba Inu. 2 is going to be a St. Bernard. And then we're just going to return switch breed number. Great. So now we have this breed number here. Now we can call this get breed function, and we're just going to do print, little print statement here. We're just going to say dog breed of token ID. This is this. That format, token ID, breed. Quick question, do you guys like that formatting or like this? Token ID, or like this better? Jury's still out. I think I'm gonna start moving to that one, but let me know in the comments what you guys think. But great, okay. Now we have this CreateCollectible, right? So this is actually going to kick off this AdvancedCollectible, right? Because we have to wait, and then we have to wait for a second transaction to go through. Sorry about that. So we'll wait for the transaction, and then we actually have to wait for the second transaction here. So this is where we're just going to kind of hard code time.sleep, and we'll say 35 seconds, right? We're going to wait for some amount of time. Hopefully by the time the second transaction by the Chainlink node has actually been done. So apologies, we do have to wait. And let's try this out. So now we can do brownie, run scripts, AdvancedCollectible, CreateCollectible, network, RINC B. And let's see if this works. Cannot convert none to way. Oh, I have them backwards. Whoopsies. So we're going to do this. I'm going to flip these two around. Oops. In the actual mix, they're flipped the other way, so sorry about that. Now let's do it. Quick flip, and here we go. So now we're actually kicking off this transaction that's going to create our first collectible. Okay. So we have the create has been confirmed. Now we're doing a little bit of a quick sleep here, and we're going to be waiting for that second one to be emitted. So, or that second transaction to happen. So we could probably even do this. We could probably even just do this, right? Wait for it to happen. Then we'll grab the request ID. We'll grab the token. Then we'll wait on the second one. So that's what we're waiting on right now. Dog breed of token ID 0 is Pug. And we can actually even double check to make sure that's the case, because maybe we didn't even wait long enough by going to the console. So brownie console, RINC B. And we can do the same thing here, right? We can get the most recent AdvancedCollectible by running this right here. And now we can get the breed again by doing, well, so there's only one token ID right now, which is 0. So we can do AdvancedCollectible, whoops, AdvancedCollectible.token ID to breed, oh, sorry, token ID to breed of 0. And we're actually getting 1, so we actually didn't wait long enough, so that's why I bumped this up to 45 seconds here. Because that means the token ID, the dog breed of token ID 0 is actually 1, which is actually going to be Shiba Inu. So we didn't wait quite long enough. Maybe we'll even do 55 here. So the next one we'll be able to wait long enough. But, so great. So now we have deployed the NFT contract. We've created our first collectible that's a random breed based off the Chainlink VRF. Awesome, we did it. Now we just got to do the next bit, which is going to be getting it onto IPFS so we can see it in Opensea. So to do this, we're actually going to need to create the metadata based off of this on-chain data that we have. So we're going to need to create a function called CreateMetadata.py. Okay, and then let's put it into the advanced collectibles here. Now in this, we actually want to deploy this to IPFS. We want to deploy this metadata to IPFS. That way we can have that URI and have the marketplaces actually referencing this metadata here. So now there's two different ways we can kind of do this. We can do this manually where we create the metadata and then we just upload it to like our IPFS desktop, right? We could 100% do this and, oops, we could 100% just upload it to our own, our own desktop here and do just kind of manually create the JSON and the image and everything, but we're going to actually do it a little bit more programmatic so that it automatically is deployed to IPFS. A lot of stuff here, so let's just jump into it. Def main, and let's do a quick line just to say what we're working on. Print working on plus network.show active. Now again, let's get our advanced collectible. Advanced collectible is going to be AdvancedCollectible. Let's get the length of advanced, spelled this wrong. AdvancedCollectible -1. I'm going to have to import that from Brownie again. From Brownie, import AdvancedCollectible. Great, so we're going to need to get this function, right? And why? We also need network, excuse me. AdvancedCollectible. Collectible, B-L-E. There we go, spelling is important. Now why do we need this? Well, because we need this to get the breed of the dog, right? We need the on-chain breed of the dog so we know to assign this specific token ID the correct image, right? We want, since it's a Shiba Inu, we want to actually give it the Shiba Inu, right? We want to give it the Shiba Inu image. So normally what I'll do is I'll even get the number of tokens there are. Number of tokens equals AdvancedCollectible.token counter, right? Because we have that token counter. So we can even run this right now, right? Brownie run scripts, advanced scripts, create metadata, network rinkby, and we'll be able to, oh, whoops, I should probably print this out, right? There should be 1, right? Because we've deployed 1, we've created only 1, and that's exactly what we see here, right? The more we print, this token counter keeps going up. Remember how we made this token counter? Right? It got initialized to 0, and whenever we create one, we add 1. Whenever we create a new NFT, we add one to that list there. So we can even like print, the number of tokens you've deployed. Deployed is this format, number of tokens, right? So we can run this again. It'll say, hey, here's the number that you've deployed. The number of tokens you deployed is 1. Perfect. So once we do that, we're going to actually want to write some metadata. So I'm just going to create a function called write metadata from the number of tokens and with the advanced collectible. Okay, because I want to write metadata for each one of these tokens. So if I deployed like 10 tokens, great. Each one of them gets their URI set up correctly. So let's do def write metadata, and we'll do token IDs, and we'll do the NFT contract, okay? So this is going to be the list of token IDs, the number of token IDs, and if there's 50 of them, and we can even just do this, and if there's 50 of them, it'll be 50. Again, in the NFT mix, this might be a little bit different, but if there's 50 of them, we want to set the metadata for all 50, right? So it doesn't matter how many we do, we'll just always get that. So for each token ID in range of this number of tokens, we want to have some type of metadata, right? We want to have like a boilerplate metadata so that we always know what the basic metadata looks like. So I'm actually going to create a new folder where we're going to store all the metadata. And in this folder, I'm going to do sample metadata.py. And this is where I'm just going to have the sample metadata, the metadata template. So I'm going to call it metadata template equals, and this is just where I add the metadata template. We're going to do name, that's the name, description. It's going to be blank here too. We'll do image, keep it blank, and then we'll do attributes. Attributes. And this is actually going to be a list, right? A list of attributes. So we're going to do trait type, and since we're just going to all be having the same trait types, let's just go ahead and add give it a cuteness one of value 100, right? So every dog that we're going to deploy, we're just going to give it this trait. Again, this isn't on-chain. If you do have on-chain attributes, this is where you would store them, right? So like, for example, we're just doing breed to change the name, but maybe we gave our dogs like a strength, a speed on-chain, whatever. This is where we put them. So in our create metadata folder file, we can now do from metadata, import sample metadata, right? So it's going to import that boilerplate for us. We could, of course, also add it right here. We could do like sample metadata equals, whatever. We're just going to import it from that other just to make it a little bit cleaner. And now we'll do collectible metadata equals sample metadata template, right? So we're just we're going to give this token ID, we're going to start it off with some boilerplate metadata. So they all start with some boilerplate metadata. Now we need to get the dog breed. So the breed is going to be get breed, which we can import. We can import from our helpful scripts, right? We can do the same as we did in CreateCollectible. We can do from scripts.helpful scripts import get breed. So we're going to do breed equals get breed, NFT contract dot token ID to breed token ID. Remember, because we have this token ID to breed, and we can use the token ID to get the breed. And now we're going to create a metadata file name. So we're gonna store this JSON object somewhere. So we ideally want to store it in this metadata file. So I'm even going to go ahead and create a new folder, rinkib, to store all of our rinkb metadatas. So we're going to do metadata file name equals, and we're going to make this a nice little list here. So we're going to do /metadata. So in this metadata folder, the network that we're working on, and we're going to do .format network.show active, right? So metadata file name is going to be in the metadata folder, in the rinkb folder of that, which we just made, plus the token ID, and then we're going to do plus a hyphen, plus the breed, plus .json. So we're going to be creating a file named basically, metadata rinkb token ID, which is going to be 0 Shiba Inu .json, right? This is what we want the file path to be. Now, if we've already have this, if we already have the metadata, let's do a quick if we've already done it. If path, and wait, let's import the path. If you guys don't work with path with Python, I highly recommend it. It is really helpful. So we're going to do from pathlib import path. If the path of that metadata file name, if path metadata file name dot exists, if the path is already there, we're just going to do print already found dot format metadata file name. Otherwise, we're going to create it. So we're going to say else print creating metadata file format metadata file name. And now let's create the file. So we're going to do collectible metadata. Name is going to be get breed. Right? Again, that NFT contract, that token ID to breed. Token ID, I probably should save the breed above, but so we're just going to say the name is just the breed, okay? And then we'll do collectible metadata description. I'm mixing my double quotes and single quotes. It's pretty gross, but it's fine. Description equals an adorable pup. Dot format collectible metadata name, right? Because this is just the breed of the dog. So that's going to be the description. It's going to be the name. All right, great. We can even print this dictionary that we have so far. So let's go ahead and run this. Brownie run scripts, advanced collectible, create metadata, network, Rinkeby, and we should see the dictionary that we just created. All right, perfect. And this is what we want it to look like so far, right? So as you can see, what we're missing here is this image bit. And this is going to be the image URI, right? A unique variable or a unique URL, defining where the image is actually located. So this is something that we have to upload to IPFS. And again, we also have to upload the metadata, that JSON file we need to upload to IPFS. So once we upload it to IPFS, then we can actually grab the URL pointing to that IPFS upload. So we need to upload the image, metadata. Let's get into getting IPFS set up so that we can actually do that. So the first thing that we need to do is we actually need to download the command line for IPFS. So if you just Google download command line, again, this will be in the description. You'll come here and you can just download right from one of these. All right, so just click and you'll be on your merry way. You'll know that you've done it right is if you can type IPFS and you get the command line printout here, okay? That's how we know we can do it right. And once we've done that, once we've downloaded IPFS, we can go ahead and run the IPFS daemon, right? So we can do IPFS daemon, and this will start a IPFS node on our local machine. We can even view the web UI of it by clicking this in the output here, this web UI button, and this will show us where this IPFS actually is, right? And so this is our IPFS node with the web UI, which is fantastic. So cool, so we know that it's actually running appropriately. Now, the other thing that I'm gonna recommend you guys do is you guys should download IPFS companion for your browser, right? I'm using Brave. If you're using Chrome, whatever, what have you. It allows you to actually view IPFS hashes and URLs in your browser. And I do one other thing. In my companion here, I go to settings and I change the port to 5002, just so that it doesn't conflict with my local one, right? Because if I'm running, just 5002, just so it doesn't conflict with the daemon that I'm running, right? Because the daemon here is going to be on port 5001, so I just changed this one to be 5002, and that way you can view both of them. So great. Once we have those set up, now we can actually continue on and we can move forward. So we have our IPFS running. Let's create a new shell here. And so now IPFS is going to be running on this shell, so we'll be able to know if we've actually uploaded stuff to IPFS. So we need to first, like I said, upload that image. So we're going to do image to upload equals none. We're just going to start from blank here. And in the Brownie mix, we're even going to set it so that if upload IPFS, the environment variable is true, only then are they going to do it. So os.getEnv, upload IPFS equals true. Then we're going to upload to IPFS, right? So we can do this. We'll do export this equals true. And now that that equals true, we can even do like print hello. We'll run the script again. Oh, I got to redo it. Brownie run scripts, advanced collectible, create metadata, network rank B. If OS is not defined, whoops. Port OS. And great, hello. Okay, perfect. So now that means our environment variable is there. So if it is defined, we're going to have to get that image path, which is going to be equal to, oops, I already cheated and I added the images here. But a new image path, right? So we have these images here, and if you want to just create a new image, like I said, I already added them. You can just do new folder, image, and then add the images there. I copy pasted my images from the NFT mix. You can put whatever images you want in here. Obviously, mine are these cute, adorable little puppies. So the image path, which is going to be image variable png dot format, and this is going to be the breed, but lowercase, just because I have them set as lowercase, breed.lower, and I also have replaced the underscores with hyphens. So this is the image path that we're going to upload. These are the images that we're going to upload to IPFS. And then I'm going to say image to upload, and this is going to be the image to upload to our collectible metadata equals upload to IPFS image path. So we need a new function, upload to IPFS. So the way we upload to IPFS is we're going to call this API, right? We're going to call the IPFS API, which is located here. And how we would do this with curl, if we want to do this with curl and just kind of raw upload it, we can do this. We can do curl -x post -f file equals at image /pug.png http://localhost, or for those of you who don't know, 127.0.0.1 is also known as localhost, port 5001/API/v0/add, boom. And this will give us a hash, and it'll give us the response. So this means it was successfully uploaded, and here is the hash of that. And we can even check to make sure that this is right by going to like a pinning service like Pinata or something. So I've already logged in to a Pinata service here. I highly recommend you guys get a Pinata service as well, or at least check it out. And I've even already pinned it here. Let me just remove it. This way you won't have to have your node up all the time, right? Because if your node goes down, nobody can see the images. Somebody else needs to have pinned this image up to. So I would highly recommend using Pinata. So we can even add this CID here, pug.png. We'll give it a name, search and pin. Great, it's been added to the queue. We'll refresh, and great, we have it here. And if we click on it, we can see that the image hash has been uploaded successfully, which is fantastic, right? And again, the reason that this is rendering is because we have our IPFS companion working here. So great, awesome, so we've done it here. So that's how we successfully upload them with the curl. Now we want to do that exact same thing with this curl. We want to do it in Python, right? We want to do it. We want to do it the raw Python way. So let's do this def upload to IPFS. It's going to take the file path in. Now we're going to do with path file path dot open for the binary as file path. Once we open this, we're going to say image binary equals fp.read. IPFS URL is going to equal this localhost HTTP localhost 5001. And then if you're using the mix, you'll see like if os.getEnv IPFS URL, use that. You can absolutely follow the mix as well. The mix also uses a .env config. You can read a little bit more in the mix if you're following along there. But so this is kind of the base URL. Now we're going to make that request to it. So we're going to say response. We're going to make that API call equals requests.post IPFS URL plus this endpoint, that endpoint that we just called, which we can find going to the documentation here. The IPFS API documentation, which we know that this endpoint adds a file or directory to IPFS. So we can say plus API/v0/add. And now for files, this is how we do that file at syntax here. Files equals file image binary. And we can check to see if this worked by doing print response.json, right? And we should get that same response that we got when we called it like this. Oh, and we also have to import requests. So let's go ahead and try this by running the script. Let's see if this works. Looks like we ran into an issue here. Whoops, I passed itself in there, so I got to do image path. Sorry about that. So image to upload is going to be upload to IPFS image path, and then we're going to print the response here. Sorry about that. Now let's go ahead and run it. And great, we do get that same output that we got before, right? Name, file, hash, size. Great. And let's go ahead and delete this now because it's going to get annoying. So great, so this has been uploaded successfully, but that's not going to be the whole story, right? So that uploads it, but we still need to get that URL, that URI of this image to add to our metadata, right? So now we got to do a couple other steps. So we're going to get the IPFS hash equals response.json hash, and then we're going to get the file name, which is going to be equal to the file path dot split. We're going to do a little bit of fancy Python stuff here. -1 0, and this just gets the name of the file path. We can even print out the file name just to show you kind of what I'm doing here. This gives us shiba inu.png. It's taking this file path, it's splitting it up, and then it's grabbing just the shiba inu part of the whole file path, right? Because the whole file path is like image, ./image, and we don't want that. We just want shiba inu. So great. So now we have the file name, we have the hash, and now we have to make the image URI, which is going to be equal to https ipfs.io/ipfs/ this is where the hash is going to go. Excuse me. File name equals, and this is where the file name goes. So .format ipfs hash file name. And we're going to print the image URI. Or actually, since we should rename this, since it's not just going to be the image, this could be the image or the metadata. So we're going to call this the URI. We're just going to say URI here. Print URI and then return URI. Otherwise, we're going to return none. So great. Let's see if this works. So this should print out this file right here, which great, it does. And if we click it, if we option click it, great. It shows the picture of the pug, which is exactly what we want. And we've already, excuse me, not the pug, the Shiba Inu. And this is the hash that we'd want to pin on Pinata, not the pug that I did before. So upload CID. So sorry, this is going to be Shiba Inu.png, or is it? It's hyphen. Shiba Inu.png. Search and pin. And great, now we've pinned it, and this is exactly what we want, right? So we're going to double check to see if it is the Shiba Inu, and it is, which is great. And again, the reason that we're pinning in it on Pinata is so that if our IPFS node goes down, and when it goes down, there's another node that still has it up, so people can still access this data, right? So that's really important. So great, so we have the image URI. Perfect. So now we have this image to upload. We have everything set up. We just need to now add the metadata up, okay? So how do we actually do that? Well, we're going to go through the same process, actually. So we're going to say now, collectible metadata, right? Because we still have to assign it. Image equals image to upload, right? So now we're adding this collectible, this URI for the image that we just got to that dictionary, to that JSON object. And now we have to paste this, we have to print this into a new folder, rinkb. In this rinkb folder, right? And we're going to do with open metadata file name file, with open metadata file name, with open metadata file name, we're going to write to it as file json.dump collectible metadata file. So we're going to dump this JSON object into this metadata file. And we have to import JSON here. Then, again, we're going to do if os.getEnv upload IPFS equals true. Then we're going to do upload to IPFS for the metadata file name as well, right? So now if we run this, it should upload both of these to IPFS. We should see 2, and that's exactly what we do. So then we can even take this, copy it, go to here, add a CID, and we'll call this the same name, Shiba Inu.json. We'll refresh, we'll give it a little bit. And I haven't added this in here yet, but we could also programmatically pin these to Pinata. I just haven't added it in here yet. So if you guys want to make that improvement to this mix, please do. But we've added it to the queue. We should see here any second, but if we go ahead and click this, we should also see the JSON object returned. And this is exactly what we want. This is our completed metadata. This is going to be our completed token URI for our NFT now. Now we're hosting it on IPFS. We've basically hosted our own API, which is incredibly exciting. And we can see that it is indeed added here. It is indeed added to our pinning service here. Awesome. This is so exciting. Now, for those of you who kind of want to skip over some of this stuff, skip over the programmatic stuff, I also added like this cheaty little dictionary in the NFT mix here called breed to image URI that I add right here. I'm just going to copy and paste it from the mix. Basically, it takes the images of the pug, the Shiba Inu, the St. Bernard, and it has their image URI right here. And then if we don't want to upload to IPFS every time, we can just use this breed to image URI, right? So we can go down to image to upload. We can actually say image to upload equals breed to image URI of breed if actually take this down one, if not image to upload, else upload to IPFS image path, right? So if this isn't set, if upload IPFS isn't, if upload IPFS, actually hold on, excuse me, image to upload equals this. Sorry. Else this. So if this is a little confusing, basically we're just saying, if we didn't upload this to IPFS, then we're just going to use kind of this cheaty thing up here, okay? And great, and we'll still get the created metadata, but we have it set to be true. So when we run this, we are indeed going to get the metadata object. But now we are also getting this stopper here saying, hey, you know, it's already been found. You already made it. You don't have to make it again, which is great. That's what we want because we do have this correctly made, right? We'll even format it here. We can see that in our metadata file, this is indeed correct. So, perfect. But this is perfect. We've uploaded our images to IPFS. We've uploaded the JSON to IPFS. Now all we need to do is set the token URI of that token that we've deployed, right? Let's even redeploy the whole thing, right? So in our scripts here, now we've got a couple of scripts. So I'm just going to redeploy the whole thing. So Brownie scripts, excuse me, Brownie run scripts, advanced deploy, network rinkeby. And again, you don't have to redeploy from scratch. I just want to redeploy so I can, let's just redeploy and see if everything's working as expected here, okay? Advanced collector deployed to here. Let's even just copy this. Great. Clear. We're going to do Brownie run scripts, advanced. It's been deployed. Let's create a collectible. Network rinkeby. We can even go to rinkeby etherscan. This is our contract here now. It's been funded. We're calling CreateCollectible right now, right? And remember, this is going to hit the CreateCollectible function, and then it's going to make the VRF call, return a random number, and that random number is going to be the seed of our random dog. And great, dog breed of token ID 0 is again a Shiba Inu. So we actually don't even need to create metadata again, but let's do it anyways. So we'll do Brownie run scripts, advanced collectible, create metadata, network rinkeby, and it's going to say, hey, you've already created it. So it's not actually going to redo anything. We can actually even stop our IPFS for now because we're not going to need it. Awesome. So now the last main important thing, if we go to Opensea right now, and we go to our doggy, so it might not be there right away. You might actually have to wait for a little bit. But as we can see, nothing's here. This is our doggies. This is our pug here, and it's like there's nothing about this. It is a blank picture, right? So this isn't what we want. We want to render an IPFS, render it in Opensea from those IPFS images and metadata that we just gave it, okay? So how do we do that? Well, let's create one more script called setTokenURI. And this is going to be the last script that we need in order to set the token URI. So we're going to need to get from Brownie, import AdvancedCollectible, because we need that contract, and we're going to need a whole bunch of other stuff. We're going to need from scripts.helpfulScripts, import get breed, and probably some other stuff, but let's just go ahead and start doing it. So def main. print working on plus network.show active, just so we can see the network that we're on. And then of course, we need to import the network. So we can do brownie, run scripts, AdvancedCollectible, setTokenURI, network rinkb, and it should just say, hey, you're working on rinkb, working on rinkb. Great. Advanced collectible. We're going to do that same syntax as before. We want to get the most recently deployed one of these. So we're going to do AdvancedCollectible length of AdvancedCollectible -1. And then we're going to just do a quick print to get the number of tokens that we have. Print the number of tokens you've deployed is, and then let's actually get the number of tokens. Number of advanced collectibles equals AdvancedCollectible.tokenCounter. Oops, token counter. Because remember, every time we deploy one of these, every time we mint create a new collectible, we're actually going to increase that token counter, right? So this should tell us we've deployed just one. So let's go ahead and run this. And that's exactly what we get. The number of tokens you've deployed is 1. Now, why do we want this? Well, because we want to loop through all the tokens that we have deployed and make sure their token URIs are set appropriately. So what we're going to do for each token ID in range, number of collectibles, so we're going to loop through all the collectibles that we've created. Let's get the breed equals getBreed, right, from that function that we imported from the helpful scripts. GetBreed of AdvancedCollectible.token ID to breed, right? Because again, we have that mapping in the AdvancedCollectible called token ID to breed of token ID. So we're going to get the breed. And we're going to check to see if we haven't already set the token URI. So if not AdvancedCollectible.token URI of token ID that starts with HTTPS. So I know that there's kind of a lot here, but remember we have the AdvancedCollectible contract has this token URI function imported from the ERC-721 of token URI that starts with, right? So we're going to say if this token ID doesn't have a token URI that starts with HTTPS, then we're going to set it, right? So remember how we did when we actually deployed, when we actually create a collectible, we're actually currently setting the token URI to none, right? So another way we could actually do this is we could say, if it does start with none, then we want to set it, right? Either one would work. So we're basically saying if we haven't set it already, let's go ahead and set it. So I'm going to print setting token URI of .format token ID. And then we're going to set the token URI. So I'm just going to go ahead, I'm going to create a new function called set token URI of token ID. And we're going to give it the AdvancedCollectible. And we also need to give it the URI that it's needed, right? That JSON, that metadata JSON thing that we printed out before, right? Because remember above, it was actually printing it out for us, okay? So what we could do is we could actually save that printed out, string, that printed out string. I actually already saved all of them. I've already saved all of them, and I'm going to cheat a little bit here. And I have this thing called dog metadata dictionary, which has the hashes of the metadata of all the dogs already. So I cheated a little bit, but yes, another way you could do this, and probably a better way too, is maybe in your metadata file, So we have the shibinu.json. Maybe you have like another folder in here that's like urls.py or something, or urls.json, right? And it just has, you print this list in here. So I think that might be a better one, better way to do it, but I'm just gonna go ahead and cheat a little bit, copy and paste it here. So I'm just gonna say, I'm gonna pass dog metadata dictionary of breed. So if it's a pug, we're gonna get the pug one, Shiba Inu one, St. Bernard one, right? Because we wanna set the token URI of the token ID on the advanced collectible contract with the correct token URI. And I know there's a mouthful here, but we're getting there, I promise, we're getting there. So let's create this setTokenURI function. Def set underscore token URI, and we're gonna take token ID, NFT contract, and token URI. So what do we need to do? Well, since we are going to make a transaction, because remember on the AdvancedCollectible.sol, setTokenURI, it's a transaction that we have to make. It's a function. We're going to be changing the state of the blockchain. So we do need that account. So we got to do this accounts.add again from config, wallets, from key. And this means that we need to import config and accounts from key. Great. Now we can call NFT contract.set token URI of token ID and token URI, right? Remember, if we go to the AdvancedCollectible.sol, it takes the token ID and the token URI. So token ID, token URI, and as always, we have to do from dev. And then we're going to do a little print here. We're going to print, awesome. You can now view your NFT at here. .format. And I'm also going to do one more cheaty thing. So I know the Opensea format of these NFTs. You can, of course, just literally copy paste from here, right? Boom. The format is going to be the address of the contract and then the ID of the token, right? So we took that, we put it into this Opensea format variable, but we variabilized out the address and the token. So we're going to take this Opensea format thing and we're going to say Opensea format dot format token, or excuse me, NFT contract dot address and token ID. Oops, token ID. And we're going to do one other print, just because sometimes Opensea can be a little bit slow. Please give up to 20 minutes and hit the refresh metadata button. Oops. Refresh metadata button. Because sometimes it can be a little bit slow. So if we've done it, I'm not going to run this quite yet, but if we haven't set it, we're going to go ahead and set it. Else, we're going to print, oops, I always hit that. We're going to print, skipping this. We've already set that token URI. Dot format, token ID. Whew, all right. A little bit of moment of truth here. So let's run this. Brownie, run scripts, advanced, set token URI, network, rinkb. And if we did everything correctly, all of that IPFS stuff, both the metadata, the JSON object, is going to be attached then to our NFT, and we should be able to see it in Opensea. Let's go ahead and run this. Number of tokens you deployed is 1, setting token ID of 0 at this transaction. Let's see what happens here. Side note, I drank a whole sleeve of brisk iced teas in recording this. Probably not necessary for you guys to know though. And okay, great, we have this output here, and I'm kind of in the way, but that's fine. So awesome, you can now view your NFT at here. Please get up to 20 minutes. So let's go ahead and click this, option click, and hopefully we've done it right. So we see right now it's blank. Let's go ahead and refresh metadata. And it worked! We have our puppy here! And it says Shiba Inu. We have the image of the Shiba Inu here. We can even go look into the details. We can see its cuteness level 100. We can see that we've recently made it about 18 minutes ago. I waited a little bit. Opensea was being a little bit slow. I fast forwarded here. But now we can do whatever we want with this. We can transfer this. We can share this with other people. We can do anything that we want, right? And we can see how powerful this is because we've uploaded an NFT to a blockchain, right? And it belongs to us. And we've given it attributes that can be viewed on Opensea on all these NFT marketplaces, so people can see what our actually looks like. Let's go ahead and sign into give this one some love, of course. Give all these some love, please and thank you. And yeah, now we can see the power here, right? And we can go way beyond this. We can make these NFTs do anything that we want them to do, right? Because all this really is a whole bunch of code. It's a whole bunch of code in here. So we can make these NFTs battle. We can make these NFTs be cards. We can make these NFTs be Pokemon. We can make whatever we want to do. We can do it here. And I know this was a long video, guys. I know there was a ton of stuff we went into. We talked about IPFS. We talked about Brownie. We talked about the ERC-721 token standard. We went into a lot of stuff, but we finally made it. We deployed it from totally scratch, from the beginning. We deployed it to a testnet, and this works the same on mainnet. It's going to be the same thing. Some of the addresses are going to be a little bit different, but at the end of the day, it's the same thing. Thank you all so much for watching this video. I know this was a long video. Please leave any questions or comments in the comment section at the bottom. There'll be a whole bunch of links in the description as well. Feel free to join the Discord, ask some questions on Stack Overflow, reach out for support. Super excited that you're beginning your NFT journey here, and hope you guys learned something, and we'll see you then. Thanks. Oh, and like and subscribe for the puppies.